Okay, sounds good. Yeah.
So good morning, everyone, and welcome to today's weekly career class. I am your host, Mr. Samarth Solomon. As you would know, we meet here every Saturday to hear from industry experts on careers, opportunities, etc. Right? And so likewise, today we have with us Ms. Shivi Sharma. She's a data science professional, and she'll be talking to us about careers in data science. And there's a lot of hype about this topic. So I would request you all to, please keep your questions prepared for the speaker. We'll be having a Q&A round at the end, and we'd love for this session to be as interactive as possible for your benefit. So before we go ahead, I'll introduce Ms. Shivi quickly. She's a data science professional with over 7 years of experience. And she has a strong background in fintech. She has also worked in companies such as American Express, Uber, etc. She is proficient in quantitative analysis, statistical analysis, algorithms, and and some programming languages, with a track record of success in building credit and fraud risk strategies for financial products. Ms. Shivi, she is passionate about financial inclusion, universal access to technology, and education. And I'm sure she'll elaborate on this a bit later. So very pleased to have you here, Shivi, and welcome onto our platform, and looking forward to this session. So without further ado, I would, ask you to take this forward.
Yeah, thank you so much, Samarth, for having me here. Thank you, IDC, for this wonderful collaboration. Let me quickly jump on this. Okay, so before we get started, as Samarth said, this is a very hype word, careers in data science. Everyone is very curious to learn more about it. So before we get started, I would love to learn from my audience, which is your favorite AI-driven app? As an example, I would say for me, the latest one is ChatGPT. I find wonderful use cases through it. Before ChatGPT's arrival, I think it used to be the recommendation system and the recommendation system for social media that particularly fascinated me a lot.
Yeah, we have some people saying ChatGPT.
Yeah, I think ChatGPT is the most recent fascinating example. But yeah, there are more to it. And today I'm here to discuss more about the different careers in data science and how you can make a head start to it. So a quick introduction, I'm Shivi Sharma. I'm a senior data scientist working with a fintech startup in San Francisco currently. My journey has been mostly with applications of data science in financial services companies and fintech companies. I love solving problems for banking, payments, and e-commerce. And I'm also the co-founder of DataBit, which was previously CareerNub. We'll talk more about each of these in the coming time. Quick overview of my journey. I did my engineering from NSIT and University of Delhi back in 2015. And my first job was with an e-commerce company called Snapdeal, where I was working in pricing analytics and optimization. So my role was to determine the optimum price for products that go to customers, deciding what discount should be applied to each of the products, and how do we determine what percentage of bank discounts should be applied, etc. Post that, I moved to work with American Express, where I got fascinated with management of risk and fraud for credit card products. And I worked with Amex India for a couple of years on resolving issues related to disputes and improving merchant data quality before I moved to American Express, New York. Post that, I worked with Uber. With Uber again, as working in the Uber payments team, where I was responsible for reducing payments fraud and capturing or identifying fake riders and who would exploit promo discounts, etc. Post that, I moved to work with a fintech company, a fintech startup called Varo Money. It is a nascent stage, very early stage bank, which is coming up in US. And we are working on providing financial access to underbanked population who do not have access to banking products yet. At Varo, I'm managing risk for fraud, payments fraud, identity, onboarding, and the broader portfolio. Uh, correspond like while I'm still working with Varo, I co-founded this company called DataBit because I was very passionate about democratizing access to data science education. And we use a case study based approach to solve for data science problems and to teach data science in a way that focuses on problem solving skills using real industry data. With that, as we all know, AI and data science are both very buzzwords, but what is AI and what is data science? Let's learn here. So artificial intelligence is a technology to create artificial systems that can mimic human intelligence. That's the broader AI term. Data science, it's an umbrella term for multiple statistical techniques, which deals with extracting data, processing it, and ultimately bringing it in a format which is useful to make important decisions. Data is captured everywhere. When you browse internet, when you open any app, the moment you log in, to how you're navigating through different apps, what kind of links you are clicking, what kind of content you are seeing within the app, how are you navigating the app flow, everywhere your data is being captured. But what do we do with this data and how do we make the best use of it to drive decisions? This is what is done in data science. A lot of people ask, what is the role of data in AI and what is the role of machine learning in AI? So I see it as a three-layered phenomena where data comes at the bottom. Without data, there is no AI. It's all about availability of data. So the first step is always collection of data. Machine learning is a subset of AI where algorithms have the ability to automatically learn from data without explicitly being programmed or assisted by domain expertise. Before machine learning, everything had to be coded in computers in form of rules. After the arrival of machine learning, algorithms have become so smart that they can identify patterns from the data themselves and give results which are intended for good users. Key pillars of data science. This is very important. So there are multiple kind of roles within data science. So we need to understand whenever anyone says they want to be a data scientist or they want to work in data science, what pillar of data science is more interesting to you or what fascinates you? It's very important to understand that in your early years of career. So the first component is data engineering. I'll talk more about each one of these in more detail in the next slides, but keep in mind these broader components for now. Data engineering, data analytics, data visualization, data modeling, and ML engineering. Now, what is data engineering? Data engineering is the practice of designing and building systems for collecting, storing data, and analyzing data at scale. When you deal with 1,000 rows or 10,000 rows, or maybe even 1 lakh or 10 lakh rows, maybe Excel, Microsoft Excel, or Google Sheets could be used to process data or to work with that data. However, as the volume of data increases, it needs special kind of systems to deal with such big data volumes. And that's where data engineering comes into play. So data engineers work at the very first layer of data ingestion and bringing it in a format that can be consumed in further stages. The next step is data processing. The raw data that comes in, it's not clean and not in a format that can be used. In order to draw or extract insights from it, We need to prepare it, clean it, remove any outliers, deal with missing data, etc. Then the third thing comes data analysis. This is the practice of looking data from different angles to find insights that can drive business decisions. In business or in industry, there are a lot of experiments that are conducted. For example, even if an app wants to change its color of the background color, there are various experiments conducted, whether we should to go with the change or not. And as a data analyst or a data scientist, the role is to conduct these multiple experiments and draw insights from them. That requires statistical knowledge. So all these data analysis, data science concepts, you need to have basic knowledge of statistics for them. The next thing is data visualization. Once you've drawn insights from data, it is important to present it in a format which is easy to consume and easy to understand by everyone. Finally comes machine learning, which is the application of advanced machine learning algorithms that can learn from data to guide you. And when you have coded or created models on your local system, these machine learning models need to be deployed, which is again a part of machine learning engineering, the last component. So this is what completes the flow of data science and data science applications in any industry, in any role. AI applications. I think we all hear about AI, how it's changing everyone's life, etc. So the broader AI applications, I see they're broken down into these 6 components. And these are the machine learning applications or the AI applications that are changing life for everyone now. The first is prediction or forecasting. How do we use the historical data sets to predict what could happen in the future? For example, read the historical weather attributes to find whether it would rain today or not. Classification. Classification is a typical example of classification is in my industry, the fintech industry, where we use data to identify whether a new transaction could be a good transaction or a fraud transaction. So classify things, classify users, classify objects into certain categories. The next typical application is clustering, which is grouping of similar objects or similar people in a way that you can target them in the same way. For example, people who are passionate or who love or have a history of buying only branded products, they could be clustered in a specific way. People from a particular region in the country could be clustered in one segment. So this is a typical example of clustering, and we have tons of algorithms that solve for each of these problems and each of these purposes. The next in queue is personalization. I think no one in this world is spare of this. So because you see your Insta feeds, which are personalized, you see your ads, which are personalized, the e-commerce recommendations are personalized. So personalization is everywhere. Natural language processing is dealing with text data and drawing insights from text data, understanding the tone of text data, summarizing a text data, paraphrasing it, etc. They all lie under natural language processing. And finally, computer vision, which is used to identify certain objects using image or maybe a face detection could be a good example. So these are the broader AI applications. And we see that AI is reshaping every field. So we talked about these applications. Let's see how it's changing the world. I think the social media is something that we can all relate to. What comes to your feed on Instagram is driven by AI. Chat bots, Chat GPT is the most upcoming example. E-commerce, your product recommendations that you see are all driven by AI. Entertainment industry, your Netflix recommendations are driven by AI. Finance, all the fraud detection happens through AI. Health, early diagnosis of diseases happens through AI. So AI is indeed revolutionizing each and every industry and has the potential to improve our lives further. Before we move into skills required, I would pause for a moment to see if there are any questions.
Yes, Shivi. So there's one question. What areas in mathematics or chapters are useful in data sciences?
Okay, let's move into questions after I cover the skills
Okay,
required, because I'll be
sure.
covering a part of it there.
Sure.
Okay, so let's continue and understand what are the skills required for becoming a data scientist. The first and the foremost is analytical and data science skills that we talked about. This includes, and the question was rightly about what math skills are required. I think the most important mathematical skill is simple maths, honestly. You should have a really good sense of numbers, how the numbers play with each other. The next is having a good understanding of statistics. If you're talking about mean of a number, how close it is to the mean of population. Are you talking about a sample mean or a population mean? What is the confidence interval? Are you talking about the point estimate or a group estimate? So these really basic mathematical concepts that we study maybe in class 6 to 10th, they are the most important ones. And then statistical, how to derive these algorithms, those concepts that you study in class 11th and 12th, like calculus, integers, integrations, etc. So the broader concepts of analytical or data science skills are the ones that we talked about earlier, like data engineering, data analytics, and data visualizations, etc. The next is industry and domain knowledge, problem solving, stakeholder management, and effective communication. These are the 5 key things that any data scientist require. And to implement these, you need SQL and Python. They are the bedrock tools for any data scientist. You have to be really proficient in these two languages. They're bread and butter in the daily day-to-day work of every data scientist. Most students learn these languages during undergrad school or while they're in college. I think SQL is taught in class 11 and 12 for some people, but you can always pick up this in college. The next is industry knowledge. You need to understand the product ecosystem. Unless you understand what problem you are tackling, you won't be able to gather the data which is required to solve that problem or think like a data scientist to solve that particular problem. So industry knowledge is very important. That's why you'll see, I'll give you a typical example of myself. So my data science application has mostly been in fintech industry. The concepts are same. You can always apply those same concepts in any other industry. However, the knowledge of industry, it really matters to really solve the problem well, because the metrics, they vary by each industry. The kind of metrics that you're tracking in an e-commerce industry will be very different from the kind of metrics you are tracking in a fintech company. So that makes a lot of difference. Plus, you need to be aware of industry trends. The third is problem solving. So finding the capability to find a problem, to evaluate a problem, to implement a solution at scale is indeed challenging. Because the problems in industry, they are very ambiguous. Nobody tells you that this is XYZ that you need to achieve. Nobody is going to give you detailed step-by-step guide. So this is one of the typical examples that I would say, like, I learned in my first job. After stepping into job, I thought that my manager would would ask me to solve and would tell me what things to do. However, the reality is that as a data scientist, you are closest to data, and people in the company expect you to tell what is hidden in the data. So the problem solving skills, navigating through that ambiguity, they are the most important skills to have. At DataBit, we are solving for these three key pillars: teaching problem-solving skills, imparting industry knowledge, while teaching data science skills and the bedrock tools which are required for it, SQL and Python. So we approach teaching data science in a way where we use industry case studies and real data from industry case studies to teach how a data scientist actually approaches and solves a problem in the industry in day-to-day life. You can learn more about it at databit.teachable.com. Some of the lectures are free for preview, and you can see what kind of metrics are solved in each industry. We have like across 10 case studies for each industry: e-commerce, fintech, credit risk, ride sharing, etc. So you'll see how the kind of problems in each industry vary by industry. By using the same concepts, you can solve for problems in different industries, but you need to understand the granularities or the nuances of the problems that you're solving there. Finally, the soft skills which are required are stakeholder management and communication. As a data scientist, you work with a lot of stakeholders in the company: product managers, compliance teams, legal teams, C-suite, leadership teams, operations team, communications team, etc. So while you are communicating your results to so many different stakeholders, it is very important to be able to communicate it in a way that anyone who's not from data science background understands the rationale behind the decisions that you are giving. For example, being in fintech industry, in the fraud industry, I come up with a recommendation that we should not allow users to do transactions greater than $5,000 if they are located outside the country. The marketing team has very different goals. There would be a conflict for sure. They'll say that, no, we want to expand the customer base there. So we need such transactions to happen. So the ability to resolve such conflicts, the ability to explain the rationale of your decisions to a non-technical audience, and having a detailed documentation are again very important skills. And in interviews, you will see that you're judged other than your technical skills, of course. You are asked about scenarios where you can answer questions related to how do you deal with such situations in your professional life. I think that's all I had to say. I will open the floor for questions now.
Sure, Shivi. Thank you. Thank you for that insightful presentation. So let's move on to the question. So we have one very interesting question. So I'm not sure if you're aware of this, but in India, traditionally we have three streams for students when they are in class 10, they are supposed to choose for their +2. Right. So there's this question someone is asking, which stream should I choose to become a data analyst? Should it be science or,
Yeah, a very good question. See, for data science, the basics that you need are maths and statistics. So it's ideal that you choose science because you get to learn maths and statistics, and you get an early exposure to some coding languages if you go in that direction. Having said that, there are ample examples of people who enter this industry with an economics background or with a stats background after choosing commerce. So they might take commerce with maths, but again, maths you need to have. So there's no running away from it. And even if you choose those fields, like even if you go with economics or statistics, you'll have to learn basic coding skills in SQL and Python. So the core skills which are required, they stay the same. However, there can be different routes to enter the industry.
All right, so I have a follow-up question here. So, having said that, we will, have people who may have, completed their +2 in, let's say, humanities, and they may not have maths background as well. Okay, they would have studied math till only, say, grade 10th. They would know just simple math and and maybe they may not be like very good at it. So for such people who still, want to make it into this field, what would you suggest? What would be some of the resources? Because I see you mentioning basic stats and basic math, right? So what would be, some of the resources you would recommend them so that they can work on these skills?
I would recommend picking up these skills. Pick up any book that teaches statistics for data science, and you learn about concepts like mean, root mean square, standard error, variance. So you need to understand these concepts really well. So pick up any book that teaches these concepts. That's the beginning point. Then move on to understanding, learning these languages like SQL and Python through any resources available. Then comes understanding the industry better. So I think at DataBidar, again, I would bring that as an example. We try to integrate these three skills like problem solving and industry knowledge and the technical knowledge that is required for anyone from a non-technical background to be able to just solve the problems related to data science. So you can pick up any of the resources. To begin with, I would recommend start learning statistics and then move on to understanding these concepts. Once you have a really good hold on these concepts, only then you should move to advanced algorithms like advanced machine learning algorithms for any of the applications that we talked about.
Sure, Shivi, that helps. And would you recommend basic stat, a good knowledge of basic stat for even those who want to, learn, let's say, a data analyst job, not scientist?
Yeah. Even for data analyst job, you need to have statistical knowledge because, as I said, every decision in the industry is driven by experiments now. So if you want to read the results of experiments, if you want to design experiments, you need to have that basic statistical knowledge around standard error, variance, p-value, etc.
Okay, sure, Shivi. So we have another question which is very similar. I'm a BA English graduate, and so would I be eligible for this job? So we have already discussed that, right? There are some hard skills that you would have to work on, such as Python and SQL. These are the bedrocks, right? To be able to work in this field. Plus, you should have a basic knowledge of stat and maths, right? So you can pick up any book for that, which helps you understand stat concepts for data science. So let's move on to the next question. Yeah, what areas or chapters in mathematics are most useful in data sciences?
The most useful chapters, I would say, as I said, the basic ones you should understand the basic algebra well, first of all. Having a good hold on numbers is very helpful, although of course, you have access to calculators and stuff. But a basic sense of numbers, for example, looking at data, you should be able to tell whether it makes sense or not. For example, you cannot say that 1,000 people who purchased 10 products made 100K in revenue. It has to total up to 10,000. So something like this basic sense of maths that you can really see the numbers and tell, okay, this doesn't make sense. That is the most important skill to have, the basic number skills. Next comes algebra. The third is integrations and stuff. Although you don't use those kind of things like integration in your day-to-day knowledge, however, having a good sense of it would help you understand the algorithms better and the application of algorithms better. So it's more advanced, but the basics ones, I would say, again, algebra and number system.
All right. So Shivi, could you, also, I know you already spoke about this from a different lens, but could you, throw some light on the usual work day of a data scientist or analyst? Like, what would it look like for you?
Yeah, sure. I'm happy to talk about it. Also, I think adding to maths concepts, probabilities again, probability, permutation, combination, those are again really important concepts to understand. To your question, how a day-to-day day looks like, it really depends on what kind of role you are in. For someone like me in fintech industry fighting fraud, every day is different because you are dealing with a really different kind of problem every day. But it all boils down to analyzing data. So, for example, you see a spike in fraud rate on a given day. So, on a typical day, although the fraud rate doesn't spike each day, but on a day when it happens, you're digging into different data sources to find out what's happening, what's going wrong. And you start querying the data to its depth, trying to find attributes that are linking to that to really find out what's happening there. On a typical day, when things are normal, you're working on building the foundations right. So you might have launched a new capability to improve the customer experience, and you want to experiment it. So you're designing the experiment, you're analyzing the results of the experiment, you're communicating the results of experiment to different stakeholders in the company. The third typical work is data visualizations. So whatever work you're doing, you need to be able to communicate it in a way that audience can or the stakeholders in different teams can understand. And finally, there are some long-term projects that you're always working on. For example, application of some data science algorithm to forecast things for the future or to build your recommendation systems better for more personalized experience. So I think a typical day is always a mix of some long-term project that you're working on and some firefighting and some conflict management, stakeholder management, etc.
Thank you so much for that. It was a very insightful answer. So one question we have, can a student of 8th standard start data analytics course at this early age? And also this brings me to another question. You know, you see so many courses out there in the market on data science, data analytics, and a lot of them also promise you placements and all that stuff. So would you like to throw your throw some light on that and your opinion on that?
I would say for someone in 8th standard, keep your fundamentals strong. Uh, it's a very buzzing industry. You might want to learn the applications of it better, and you might even find applications of data science in your day-to-day life if you're very passionate about it. However, don't miss the fact that having those fundamental skills is very important, like critical thinking, problem solving, evaluating ambiguity. And it doesn't necessarily comes from learning SQL or Python. It comes from it comes from many different things. For example, maybe at this age, it's a good idea to read a lot, to understand different industries better, rather than entering into core core technical languages, because languages change rapidly. I started with when I started my data science journey, I used to have R, and R, most of the things were done on R. I think it's already going away. There are hardly any people using it. So languages, the syntax, those could change. However, the approach to problems, the judgments you make, that comes with a lot of different things. So get your fundamentals correct at this stage.
Thank you, Shivi. So the next question is, will you suggest someone to switch his or her career to data science in his or her early 30s?
You can switch careers anytime. I really believe that if people want to do it, there's no good or bad age. But you need to prepare yourself and prepare your mind that when you switch a career, you might start from levels that you might not want to. That's the main trade-off. For example, even as a data scientist, if people, or I'll take an example of a product manager who's been in the industry for, let's say, 5 years or 6 years. If they want to move into data science, they might want to take a level cut. See, as long as you are prepared mentally to learn new things and take those kind of cuts, you can always take the dip.
All right. So the next question is, what does data visualization require?
There are many data visualization tools. If you want to get started, I would suggest you can explore Google Data Studio, which is a free tool available. You can just have some data in Excel sheet or a Google sheet, upload it and start playing around. Data visualization is the art of showing data in a manner that people understand. And you need to have some basic understanding about what kind of charts would represent that data better. For example, when should I use a pie chart versus when should I use a stack bar chart versus a bar chart, etc. So those kind of having a good understanding about the different kind of charts available, the different kind of visualizations available, what kind of visualization do you want to use to communicate your findings? That all comes under data visualization. In industry, Tableau is the tool which is used the most. And to build data visualizations, you need to have some basic skills which are required for building data pipelines as well. And having said that, it means that data sits in tables. You need to show it in a way on Tableau. So you need to build a pipeline, like you connect the backend water resources to your tap, it comes through a pipeline. You can just visualize it in a similar fashion. So in order to carry the data from the tables to the main charts, you need to build those data pipelines. So all these are a part of data visualizations.
All right. Thanks for that. Also, someone is asking, is it like Excel charts? So I think there is a huge difference between such powerful tools and Excel. So maybe you can throw some light on that.
Yeah, Excel comes handy when the volume of data is less. When the volume of data increases, as I said earlier, uh, Excel won't be able to deal with that data. And tools like these, they have the capability to refresh data themselves through the data pipelines that I talked about. So no one has to go and manually refresh it every day. As soon as the data in the tables, backend tables gets updated, the charts get updated. So it's those could be real time, those could be batch runs, but the main capability is being able to handle large volume data.
All right. So there's one question, and you might want to give some clarification here. What is the minimum percentage required in graduation for this course by IDC? I think you might want to clarify here.
Okay, the course, maybe the person is referring to the DataBit course that I referred to.
Yes.
Yeah, there's no minimum percentage required. It's for anyone who's starting off. It's really literally 0 to 1 in data science, and we mean it. So the course begins with basic SQL syntax, where you learn the first basic query, select what column name do you want to select, etc., from what table name. And thereon you learn to master skills like maybe what is the cumulative sum of sales that happened in a given day for an e-commerce company, etc. No minimum college percentage. You can pick the skills at any age with any percentage.
All right, thanks for that. And also, we often get this question asked, how much time would it take for me to say, become a professional data analyst or scientist? So how would you want to, approach that question?
I would say you need, if you dedicate yourself completely and you are starting from scratch, 6 months you should give yourself to make yourself or start feeling comfortable to even start interviewing. So you all the concepts, if you're very new to the industry, having a good hold or understanding of all these statistical concepts, these languages and these different components, algorithms, etc. Practice. You might want to build some portfolio. That's very important these days. I think when I started off, there was not even a term called data scientist. It's relatively a very new industry. It always used to be there. People were called statisticians back then. It's become a buzzword, data scientist now. So you really need to build a portfolio project after learning these skills, where you can show how you applied these skills on a real life problem. So all that requires at least 6 months of time, I feel.
All right. Thanks for that. Now, one more question. Any text and reading that you would suggest to enhance critical thinking and problem solving skills?
Yeah, that's a good question. There are a lot of great books on it. I can recommend a few. In general, I think reading improves your critical thinking skills. For problem solving, I feel it should be it's a temperament. So whatever problem you see, if you think in a direction of, instead of saying that, oh, it's such a and we don't like it, or you being frustrated by it, if you start thinking, yes, in the direction of solving that problem, you develop those problem solving skills, and you really need to imbibe that attitude in your day-to-day life. That's how things work in industries as well. We cannot play that blame game. Like, hey, that person did not do this, that person did not do this. When you identify a problem, just think about how you can solve it. And it can be anything. Even in fact, like in interviews, it's appreciated if you give some examples from your real life to show this kind of attitude. So next time, whenever you say, or say the government is not doing good, or that person bothers me, just take a step back and think, okay, that people might not be doing the things correctly. What can I do to fix it? That's the main problem solving skill attitude.
Okay, thank you. So again, we're getting a lot of questions asked on resources, resource recommendations for data visualization. Also, if I am good at Excel and Tableau, what's the next thing I should do to become an analyst?
To become an analyst, I would say data visualization, as I said, it's just a component. If you're good at Excel and Tableau, that's great. Next step should be to master your SQL and Python skills, and to learn about product metrics which are tracked in industries. So just make yourself familiar with the kind of problems that are solved in industries, and try to apply your SQL and Python skills to solve those problems.
All right, thank you for that. So let's wait for a few minutes. If anyone has any more questions, you can put it in the chat. And I think we'll just take one or two more questions now, and then we'll be concluding the session.
Sure, it's really nice to see such interesting questions coming from really young students. Very nice to see such curious questions from young age students. Very nice. I would love to know. I don't know if I can reachable, but are there people in school, or in college, or in your early stage of career, whatever stage you're in, if you're thinking about this career, just keep your fundamentals strong. And that is the most important thing, I feel. Yeah, you can solve problems in any industry as long as your fundamentals are strong.
So we're already receiving, very good feedback for your session, insightful and simply presented. So also one question now, can you suggest few good colleges for data science?
Data science is, as I said, it's a very new field. Not a lot of colleges until now had a course focused on data science. People from engineering background, from statistics background, can enter data science force. Having said that, I think the focus should still be on your energy should be directed to being able to crack a good college, if that's the idea. Most of the data science specialization courses, they happen at master's level. In India, Indian Institute of Science, ISC, and Indian Statistical Institute, IITs have started masters in data science. Those could be a few good options. And abroad, there are a lot of universities that have started masters in data science, masters in business analytics courses. In order to crack those things, just be aware, keep yourself updated with the requirements of being able to enter into courses. In India, most of the courses require some entrance test, maybe followed by interviews. Foreign universities have a different application process, mostly GRE followed by an interest, why you want to pursue the course, and you need to have some letters of recommendation. So just keep yourself updated with those requirements and prepare for those courses.
Sure, Shivi. So now we'll be, taking up the last question for today, which is, why don't you, Shivi, tell us about in brief, about your journey? How did you, were you always in data science, or did you transition to this field? How was it like for you?
For me, I would say it was a serendipity. I was doing engineering, and my majors in engineering was instrumentation and control. However, data science was relatively very new, upcoming industry back then. So I got very interested, just curious to learn, fascinated by the idea, I would say, how data is being used to solve business problems. And that was the main driving factor. And I found a good internship during my third year that had applications of data to solve basic problems in industry, in my own industry. Like back then it was a core instrumentation industry, and I learned how can we use data to determine at what frequency should we shut down some pipelines or something like that. So that made me curious. And e-commerce was again a very new industry 8 years back, very upcoming. So the intersection of application of data and learning more about e-commerce industry was something that drove me, and I decided to interview with this company and finally join it. After my first role was dealing with applications of data in pricing analytics and determining what should be the optimum price for a product. And somehow I was linked to some relation of price movements to fraud, like how many people try to make use of promo frauds, etc. So I got really fascinated about with the application of data science and catching fraud. So I decided to go and join a financial services company, and that was American Express for me, where I could learn more about risk management and application of data science in that domain. Since then, I have stayed in the same industry and still learning. I don't think there's any day, any week, even after 7 years, where I don't learn a new thing, because things change so fast. The kind of trends change so fast. The concepts, the basic skills required might stay the same. However, you grow your judgment skills, you grow your industry knowledge to be able to give or add more value to the profession.
Well, thanks for that, Shivi. So now we'll be concluding the session, right? We've come to an end, and thank you so much for coming onto our platform and talking to students. To our audience, thank you for joining us in. We have shared all the relevant resources in the chat, right? And I'm also pasting iDream Careers contact details here. And so if you are, perhaps you're confused about which field to go into, you can contact us on this number. We have counselors with us, right? And yes, Shivi, would you like to add something before we end this meeting?
I loved the questions that came from the audience. Absolutely loved it. I can be very easily reached on LinkedIn. Please feel free to connect with me on LinkedIn, and I'm happy to chat one-on-one with anyone whenever you want to.
Thank you, Shivi. So bye, everyone, and we'll see you next Saturday. Yes, Shivi, did you have something to say?
No, bye. That's fine. Thank you.